Hello everyone. Thanks for watching this seismic stratigraphy video lecture. Now I want to present the part one. Let's see my screen. Okay. So this is the title or the lecture of seismic stratigraphy. I can skip this. And actually, this seismic stratigraphy is part of the uh, my guest lecture at the University of Pembangunan Nasional Veteran Yogyakarta in Indonesia, and uh, all my lecture here are following the university curriculum for the uh, undergraduate program in geology. So before you take this course, it's better if you have these prerequisites before, like in petroleum geology, sedimentology, stratigraphy, and also the basic geophysics. So today we will discuss the first part of this lecture, which is to understand the geological meaning of seismic reflection data, and to understand the definition and application of seismic stratigraphy. And the last one is to capable of doing seismic sequence analysis. For the objectives 4 and 5 is available on the uh, other video lecture in my YouTube channel. So, what is the seismic reflection data? So, this is simplification of sequence stratigraphic model by Mitchum Peterfeld and friend from ExxonMobil and University of Rice in 1877. Basically, what you need in the seismic reflection data is the interface between the lithology, where you have different rock properties between those two lithology. And in this case, the rock properties are representing by density and velocity. And if you have density and velocity of layer 1 with density and velocity of layer 2, then you will have this, what we call as the acoustic impedance. And after that, by this formula, then you can get reflection coefficient from this acoustic impedance. Convolving the reflection coefficient with the wavelet, then you can have this synthetic seismogram. That's what you see on the seismic reflection data. Next, there is some convention on the phase and polarity of seismic reflection data. So, for example, if you are in the SEG positive standard polarity, the increase in acoustic impedance is representing by either a zero phase or the minimum phase. But if you have SEG negative standard polarity, the increase in acoustic impedance is representing as a trough in zero phase and minimum phase. Another important thing in the seismic reflection data is vertical resolution, where you have to deal with this kind of vertical resolution. For instance, one wiggle of a seismic section might be correlable to a Big Bang in London. And if you compare to the logs data, which is much more high resolution compared to the seismic reflection data. And today's the conventional vertical resolution of seismic data is like 20 to 30 meters. Means that if you have layers of sedimentary rocks uh, less than 20 to 30 meters, it might be difficult to image on seismic reflection data. Also, we need to keep in mind that our seismic reflection data could contain pitfalls, which is not related to the geology or subsurface, but rather it's related to the uh, multiple, for instance, or acquisition footprints, velocity pull up or velocity push down. So it's not a real geology. So we need to be careful when we interpret the seismic reflection data. And the seismic reflection data is measuring is the measuring two-way travel time. It's measuring density and velocity of the rocks, and everything is about the rocks. So means that when we interpret the seismic reflection data, we need to understand about the geology, and then we need to extract geology, geophysics, and reservoir information out of seismic data. Because one of the thing is that seismic reflection data is very expensive data and is difficult to acquire related to the area, like for instance, in onshore area, in the jungle, or in the remote area, something like that. All right, the second objective is about the definition and application of seismic stratigraphy. So this is one of the definition by Peter Vail and Robert Mitchum in 1977 on the AAPG Memoir 26. Seismic stratigraphy is the study of stratigraphy and positional physics as interpreted from seismic reflection data. And since seismic reflection follow chronostratigraphic correlation, which means time stratigraphy, resulting the geometry of seismic reflection correlation patterns. This is just a basic exercise about the stratigraphy, where we need to restore back the layers, the strata back to the positional time to be able to create a chronostratigraphy relationship. So, what is seismic stratigraphy used for? So, for instance, you are working on the oil company, then your manager will give you a seismic section, and it's simply to ask how these sedimentary rocks deposited and evolved related to the hydrocarbon accumulation. So basically, we need to define all the petroleum system elements on the seismic section. Where is the reservoir, source rock, seal, what is the migration agent, and so on. So this one is the definite things that we need to define on the seismic reflection data related to the method, and at the end we can define the pattern perspectivity identification, geohazard analysis, carbon capture, storage identification, and characterization. So this is the workflow actually on how the seismic stratigraphy can useful to define the evolution of the basin and also for this petrol perspectivity and so on. So it consists of seismic sequence analysis, seismic facies analysis, and the relative changes of sea level analysis. So those three things that we we need to follow for the workflow on the seismic stratigraphy analysis. So next, we need to discuss about seismic sequence analysis. So this is the lateral unit that related to the vertical and horizontal resolution of the data. So in this case, we have a core and outcrop data, we have a logs data, we have a seismic data, and this is the paleo topography of the data. So as you know that in the stratal unit, we have a lamina set, bed set until the sequence. So basically, what we can achieve from the seismic reflection data is mostly on the para-sequence set and the sequence. Going, if you want to go to the details, then we need to use logs data. So what is the meaning of seismic sequence analysis? So seismic sequence analysis subdivides the seismic section into packages of concordant reflection or same genetic unit that separate by surfaces of discontinuity, which is the reflection termination, and interpreting them as a depositional sequence. So in this case, we are working on or we are dealing with depositional sequence. So on this sequence analysis, we need to define the reflection termination first. So this is one of the example of the reflection termination called erosional truncation, where we have the strata against an overlying erosional surface. So it's quite easy because then it's like an angular unconformity kind of surfaces. So where you have a dipping layer against an overlaying erosional surface, which is much more uh, flatter compared to the strata below. And another reflection termination called top lap. So in this top lap, the termination of reflection interpreted as a strata against an overlaying surfaces as a result of non-deposition, and only minor erosion. So the difference between the erosional truncation on top lab is that in the top lab you are mostly in non-deposition uh, with the sedimentary bypassing. So in terms of the sequence, it's like a continuous sequence, but non-deposition due to the sedimentary bypassing. And this only minor erosion might be related to the local sediment conduits transportation. Next is the internal convergence, where in this internal convergence is non-systematic reflection termination within sequence due to the thinnings of the strata below seismic resolution. So in this case, if you see the examples, then you will see that the internal convergence, number one here, is like uh, something's floating in the middle of the surfaces or in the middle of the stratigraphy. This is just because of the thinning upward to the proximal or to the sediment source direction. Next is the onlap. Onlap is a relation in which seismic reflection are interpreted as initially horizontal strata that terminating progressively against an initially inclined surface below, or as initially inclined strata terminating progressively up deep, means also to the proximal part against a surface of greater inclination. And this is also easy to see on your seismic section. So wherever you have these laying down the surface with the older surface, that's where you have this onlap. Another reflection termination is downlap. Is a relation in which seismic reflection are interpreted as initially inclined strata, terminating down deep to the distal part against an initially inclined or horizontal surface. So most probably that the downlap uh, reflection termination is located on the distal part of your area. And how is the termination looks like on the outcrops? So this is one of the example from Norway in Svalbard Island, where you have a beautiful uh, onlap and also onlap on this red and blue line. Also, you have a downlap on this prograding clinoform. It means that you can also recognize this reflection termination on the outcrops data. So this is just a simple exercise utilizing the Exxon slug models to locate the reflection termination. In this case, we've discussed the on-lap, down-lap, top-lap, and also the truncation. That's all for this part one. Hope it's useful. Thank you.